Up to this point in Unit 6, we've talked about inorganic fertilizers for phosphorus. Let's switch gears and let's talk about organic sources of phosphorus. And oftentimes these are in the forms of livestock manure, but they could be biosolids or other types of byproducts. And oftentimes what we see, or sometimes what we can see with the use of manures, is that you get a better return as a function of yield of a certain crop with a manure versus an inorganic fertilizer, as shown in this graph here on the left-hand side, that shows you yield on the y-axis, which is probably corn, as a function of a control, a soil that doesn't receive any fertilizer versus a phosphorus fertilizer versus a manure. And so the advantage to manure, and sometimes there's disadvantages as well, but in this case, the advantages of manure are not strictly just phosphorus. And we know this, right? We know that manures contain other elements other than phosphorus, although they do contain phosphorus, but they certainly contain nitrogen. They contain organic matter, which is a carbon source or energy source for microorganisms, which increase microbial activity, and that can enhance nutrient cycling and turnover and feed our plants with organic sources of elements necessary for plant growth. And because of microbial activity and the release or mineralization of other minerals, manures contain other nutrients that simply can feed our plants. However, there are challenges with manure. So some of the challenges, and this list is not all encompassing, but some of the challenges is simply there's no guarantee. I mean, oftentimes when you go to Home Depot or Lowe's and purchase a bag of manure for your yard or garden, there's no guarantee on the bag. There's no 10-34-0. All right. And so the challenge with using manures is that if you utilize a manure, you first should have a test performed so you understand and you know how much nitrogen, phosphorus, or potassium is in the manure itself. And you can have those tests done at any soil testing lab within the nation. In manures, there's definitely a non-uniform distribution of nutrients. So some nutrients are present in greater quantities in one type of manure and less in another type of manure, or they're in forms within the manure that are either available or unavailable. It's all over the board. So again, having a test performed on your manure is paramount for utilizing a manure. Another challenge with utilizing manure is oftentimes our manures are applied based on nitrogen needs of a crop, and that leads to phosphorus buildup in our soils. Sometimes this is called legacy phosphorus if this practice has been utilized over years. And it's not just an issue with manures, but it's also an issue with inorganic phosphorus fertilizers applied in excess over time. There's certainly compaction issues related to manure application, especially if you're applying manure in maybe the springtime or when the soils are wet or saturated. And when soils are wet or saturated, they tend to compact to a greater degree than when soils are drier. And of course, there's always increasing regulation. And with manures, that's no exception. So within manures themselves, the variation in nutrient content is all over the place. And so this table gives you a rough idea of what I mean by all over the place. So the top half of this table shows you livestock systems that handle the solid waste. And the bottom half are livestock systems that handle the liquid waste. And you can see the types of livestock and what's present in the solid handling system. We'll stick with the top half, with bedding, without bedding, blah, 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 blah. And if you go over to the far right, the column of P2O5 within these materials varies greatly. Varies from like 7 to 65% P2O5, depending on the manure source itself. So what this tells you is, it tells you roughly what you might expect if you use poultry litter versus cattle manure. But what it doesn't tell you are the exact numbers. And so having a test performed on your manures is oftentimes critical, so you know your starting point before you apply these to a soil. Some other points about phosphorus in organic amendments. So in general, manure contains phosphorus that's 80% available. All right. This is inorganic phosphorus. The other 20% is organic phosphorus that will be released over time. But 80% is a good rule of thumb to start with. But to be honest with you, if I was going to use any of those manures listed on the previous slide, I would have a test done and I would find out how much orthophosphate or soluble phosphate or available phosphorus was present in those materials. So I knew a starting point. For this class, we're going to use 80% for illustrative purposes. Point number 2, I can tell you that manures are more often than not applied based on the nitrogen needs of a crop. And when we apply based on the nitrogen needs of a crop, we almost always over apply phosphorus needs for a crop by 3 to 5-fold. And that can lead over time to issues, right? We've learned about eutrophication issues in this unit, for example. And so point number 3 is you need to consider the risk of P loss and the environmental impacts. And this applies not only to using manures, but using inorganic fertilizers as well. Now, I can tell you one caveat, and this is just FYI. Some states, not all states, but some states have something called a phosphorus risk index, and it might be called something different from state to state to state. But a P risk index, and what a P risk index does or tells you is based on the information that you put into the index, based on source of phosphorus, application rate, timing, how it's placed, and other management strategies will tell you the potential risk for off-site movement of phosphorus into areas that are sensitive to excess phosphorus, like Lake Erie, like we learned about, or some of those lakes overseas, like Lake Ellesmere in New Zealand, etc.